All right, welcome everybody. This is part of our continuing webinar series, Ask the Building Expert. Um, Glad you joined us. Those of you who are on our Zoom platform, if you have any questions, just use the chat feature or the Q&A. There's also raise hand. We can turn your microphone on. If you're on Facebook watching, you're not connected to our Zoom platform, although you can post your comments on Facebook and hopefully we'll be able to read it. So interesting topic today. Well, before I get to that, the reason why we kind of put together these series is to help people who are in the property management industry, developers. Let me get to the PowerPoint slide. Building owners, condo associations, property managers, board members, condo owners, real estate agents, homeowners, and anyone else who's interested in the topics that we have. I don't know if you can hear a weed eater in the background, but I can't tell them to stop because it's hard to get them to do any work. So just let them go. Anyway, interesting things. If you look at the photo, I was at the Millennium Tower inspecting the building, and then I was in New York inspecting this other super high-rise building. A lot of fun stuff. But today's topic is interesting. It's building envelope. It's a wrap. Now, a building envelope. Imagine if you are writing a letter and you're finished and you're folding it and you're putting the letter in an envelope and you're sealing it. Okay, so basically that's the concept of a building. The building envelope is actually the all the sides of a building to protect the interior. And we'll go through this. So what is the building envelope? It's a separation of the interior and exterior of the building. The entire exterior building system includes a foundation, walls, roof, and more. So if you take a square building or a rectangle building, say a high-rise building, how many sides of the building does it have? If it's a perfect square, okay, you have 4 sides, right? Well, what side is really visible? If it's a high-rise building and you walk around the building, if it's a perfect square, then there's 4 sides, right? But what about the bottom of the building and the top? So if you add those two, then you end up with 6 sides. So that's why we say that there's actually 6 sides to a building. Regardless if the shape is a rectangle or a square or whatever it is, it could be multiple buildings, but we're talking about one single building here. So there's 6 sides to a building. And in the construction industry or the building or property management industry, we like to say we need to protect all 6 sides of your building envelope, which is all 6 sides of the building, the 4 walls and the roof and your foundation. Now, believe it or not, there's been leaks called water infiltration conditions or water leaks or moisture migration. These are terms that are commonly used. That's coming from the sides of a building or even the roof or maybe even the foundation. Now, how can water come up through the building foundation? Well, there's many different sources or reasons why. It could be a crack somewhere, or it could be a high water table, any number of reasons why water could come through. If you have a parking deck and it's below grade wall, you could have water coming through that wall also. Now, the number one causes of lawsuits, believe it or not, and we're talking about lawsuits regarding new construction and even older construction, the number one cause of the lawsuits are water infiltration conditions. And what that means is you have water coming in from different sources. It could be mostly the rain coming into the building at your windows or at your roof or at your foundation. Now, there's other water infiltration conditions that could prevail in a building besides rain. It could be an air conditioner leak, it could be a plumbing leak. And these are mainly water that's leaking into the interior of the building. Like if you have a condo building, you have units, you have a plumbing leak, it could leak in that unit and the next door units or go down several floors. Okay. Similarly, if you have an air conditioner leak, if it's in, doesn't matter if it's a condo or shopping center, office building, it could cause leaks to other units in the building or other stores and restaurants and so forth. So what I'm going to talk about today is basically water infiltration conditions at windows or just a window system. And let's see what we have next. Okay, there's two types of walls concerning windows. Now, as you know, a solid wall could be made out of concrete or wood or steel or any kind of other material. But if you do not have a solid wall and you have openings in the wall for units or offices, then you have windows there. And so a window system in a building, there's many different types of systems, but the two main systems that are in use today is a window wall and a curtain wall. And you know, what are you talking about here? Well, window wall versus a curtain wall. A window wall is actually you have a floor, a building that's made out of concrete, let's say, and your window system is between the slabs. Okay, so it's between the slabs, and that's called a window wall system. A curtain wall system is not connected between the slabs. It's connected on the outside of the slabs by clips. So it does the same purpose, except the design and construction is a little different. So let me show you something else here. So a window wall is normally a glass system constructed between the floor slabs of the building. And if you drive around, you'll see buildings, the older buildings that were built in the 60s, 70s, and the 80s have a window wall system because you see concrete and you see the glass of the windows. Okay, a curtain wall started being developed because the designers and developer wanted more view or more glass to look out rather than concrete. So that's where a curtain wall system comes in. It's basically a glass wall system hung off concrete slabs using anchors. So if you see a lot of buildings that are all glass, okay, like this photo, normally it's a curtain wall system. And there's many buildings, the newer buildings that are being built, all the high rises have a curtain wall system, and it could be buildings that have a combination of curtain wall and a window wall system, and maybe some other systems. But for the most part, it's a curtain wall system. So if you're driving around Hawaii, Honolulu, in the Kaka'ako area, you see all these high-rise buildings going up, and it's all glass. That's normally a curtain wall system. Now, there's many of you that are not from Hawaii attending this webinar, and you could go to whatever city you live in or nearby city that's very popular, that they're building or built new construction, high-rise buildings, office buildings, condominiums, and things like that. In the bigger cities like Los Angeles, San Francisco, San Diego, Chicago, New York, this system is basically a curtain wall system. If you see it, a lot of glass. Now, what are the problems with high-rise windows? And I'm going back to the 60s, 70s, 80s, not not too much in modern times, but there could be instances of uh, new buildings having similar problems. So if you're able to see the image, if you look on the left, this is a casement window. It's a swinging window that swings up up and down, not sideways. Okay. So what's happening is if you have the window opening when you open it is too wide, then a small child could fall out of it. So even with new high rises, sometimes the window opening is too big. So it's a safety issue. The other thing is that if you have a design where there's a shelf and then a window, if you have a small kid that stands on the shelf and the window is a sliding type window, like a door, it could be easily child could fall out. Apologize for the background noise, but as you can see, I'm at my home office and it's gardening day, so weed weed uh, weed eaters are going off and things like that. I don't want to stop and tell them to come back later because they'll never show up until next month. But anyway, apologize for that. So as I was saying before, the design of a building, if you have a little shelf, and let's say there's furniture like a chair or a table or a couch, a kid could climb on the couch, go on the shelf. If he's able to open the window, and it's like a sliding window or acts like a door, that kid could fall out. And if you can see the picture, this guy is not on the ground. He's actually, maybe three, 3 or 4 stories high. So this is a dangerous condition. So that's a problem with high-rise windows. And when I say high-rise, it could be 2, 3 stories up, or it could be a 40-story building or 80-story building. Okay, so that's something to be concerned about. And why am I bringing this up? It's because it's part of the building envelope, although it's not a curtain wall system, it's a window wall system, but nonetheless, it's still a problem. Now, what other conditions are prevalent in older buildings with windows? You might say, yeah, maybe the glass is not safety glass because during the time of the construction, they didn't use safety glass. It was thin plate glass, like buildings and houses in the 50s and 60s. They have thin plate glass, and when you crack it, it leaves all these shards. It's not safety glass or tempered glass by any means. So that's a safety issue. Because can you imagine you have uh, glass that's old, non-safety, and you're in a 20-story building? If the glass cracks, what happens? Now there's a hole there. So if you look at the image on the left, that's basically glass that cracked and it's about to fall into pieces. Now, your car glass is safety glass because when it cracks, it doesn't leave shards. But the older houses have non-safety glass, non-tempered, and it could be dangerous if it cracks. Now let's talk about jalousie windows. A lot of older buildings and even older homes, that was style back then to use jalousie windows. And if you have glass jalousies as opposed to wood, the glass can be cracked. And try to find a replacement. If the glass is an odd shape, it has to be cut to size, and also the measurements are different. The thickness of the glass may be a little different. But the reason why I'm bringing this up is there's many high-rise buildings that have jalousie windows, and it's floor to ceiling, or it's floor to, 4 feet high or something like that. So the problem here is that if the window's open and it's floor to ceiling, a kid could just fall out, right? The screen is not any kind of protective device from a kid falling out of a window. Similarly, if you have a slider window, or any type that's, from floor to maybe 3 feet, that's also unsafe in a high-rise building. So just be aware of these safety issues in buildings that are 2 or more stories high. And it doesn't have to be a condo. It could be an apartment building, or it could be an office building. But I really don't see too many office buildings with that problem. Most of the time, it's residential, either an apartment or a condo building. So just be aware of these safety issues that come up. And then, if you live in a house, go around and look at your own house and see if you have these similar conditions. If you live in a condo building and it's old, maybe it's time to change out the windows because it's not safe. Now, what is my expert advice? Building expert recommendations. Well, always do inspections of the windows and carefully review it. If you need advice from an expert, consultant expert that can come and look at it and give you an opinion, and just do the proper inspections and don't wait 5-10 years before you do anything, because you always be proactive instead of reactive. Sometimes if you're reactive, it's too late already. For instance, remember I talked about the high-rise buildings with jalousie windows? I've inspected some and walked around in a parking deck, which would either be on the ground floor, or if it's a parking deck structure, I'm on the 3rd floor, 5th or 6th floor, okay? Walking around the building on the top deck, and all of a sudden there's pieces of jalousie slats crashing to the ground. Is that safe? No, that's a big problem. So my advice is, always do your inspections and your due diligence, and basically make a list of things that need to be done. If you're on a condo board, or if you're just living in a condo, if you see anything, say something to the board or property management company, and hopefully they'll take some action. Let me see what else here. Oh, let me back up. So before I get to the next part, wanted to let you know about some case studies involving litigation. There's many buildings around town, and I'm talking about Hawaii, but it also applies to other cities that I mentioned before. New York, Chicago, Atlanta, San Francisco, LA, San Diego. They all have these high-rise buildings, residential now, and most of them are condos that have water infiltration conditions. And sometimes that's a basis for a construction defect litigation lawsuit. Now in Hawaii, we have problem windows, and I've inspected these before, and some of them were unsafe. Some of them were not to code. Some of them were not installed correctly. And every time it rained, water started coming into the inside of the building. So for instance, there's a building two buildings called Yacht Harbor Towers by the Ala Moana area. They had windows that were not, although they were to code at the time, they became unsafe, and they were about to lose their insurance coverage because of the window problems. So they had to redo their windows and install new windows. There were other high-rise buildings, one of them, Ko'olani, that had water infiltration conditions coming in, not at the unit themselves, but each floor had a lobby and there was windows and hallways, and water was coming in at the windows through those areas. And then you have newer buildings such as Waiea that had window issues, and I'm not really sure if it was a water infiltration condition, but I know it was a sound problem. There were these vibrations and booming noises coming from the windows, and then they had experts come in, and it was determined that the windows were not installed correctly. So there's a whole remediation process of installing new windows, and that was part of a settlement to construction defect lawsuit. So there's other buildings, and it could be that the newer buildings now that are being built would have some similar conditions of water infiltration or noise. And when I say noise, it's random noises that have to do with the windows themselves, either like a knocking sound or expansion sound due to temperature fluctuations or different types of noises that are coming from the windows. So that's not ambient noise that it's coming from the street, like you're in your unit and a loud truck or a bus goes by or an ambulance. You can hear that noise, and that's kind of to be expected because these condos are not built to be soundproof. They're not built to be built like a recording studio, although there's expectation that you're going to pay 2, 3 million, 10 million for a luxury condo unit. You kind of expect that when you're in your unit, you're not hearing a lot of noises outside, coming into the unit. So that's something for further discussion. So basically, that's the gist of a building envelope. And I know it's, kind of a simplistic presentation, but this could get really technical, could turn into like a 4 or 8 hour presentation about specific windows and how it's installed and what the problems are, but that's not what we're here to do today. We're here to basically just give you a building envelope 101 presentation. And if you have other questions that may come up later, feel free to call or send us an email. Now, let me continue, and I want to let you know that there's other webinars coming up. But before that, we've done a whole years of webinars. In fact, more than a year, and every month we give 2 webinars on building and construction topics. And what you missed so far, probably 28 webinars, ranging from topics such as contractor licensing, hurricane ties, roofing, plumbing, cast iron drain piping. There's a whole bunch: water infiltration, waterproofing, painting, building codes and permits, and the list goes on. But you didn't really miss it. You missed the live presentation, but there's also a chance you can go to our website and catch it on demand. And we've had probably a lot more people watching our on demand that actually attended live, because we know you may have a busy schedule, you're working or doing something else, and that's why we offer the webinars on demand. So you can go to our website, askbuildingexpert.now.site, and select the one of your own choosing, and enjoy it and learn. And there's a ton of information on different topics, wood repair and things like that. Also, what's coming up, the next webinar in a couple weeks is about lot grade drainage, and then after that it's plumbing. And when I say plumbing, we're talking about supply piping. When you turn your faucet on, water comes out. That's the kind of plumbing I'm talking about. Your plumbing, different types of plumbing and things like that, problems with certain plumbing. Then next is the Millennium Story. You know, that sinking building in San Francisco? Well, it's really sinking, and I'm going to give a webinar on that. Also, if you're a condo property manager, a condo owner, or on the board, I'm giving a topic on homeowner association design review, and that's also a hot topic. And then after that, it's what to do after a flood. And I'm going to be covering not only a flood from rain, but if somehow your home gets flooded from a plumbing leak, I'm going to cover that too. And also after that, that takes us up to June. And then from July on, I'm talking about contractor bidding, avoid the ripoff. That's going to be interesting. The termite story, they're always hungry. Window safety, hazards, and lawsuits. I kind of briefly talked about windows today, but this will be an expanded version. Also, the Grenfell Tower fire, the real story. The Grenfell Tower, there was a fire years ago in London, and it was an apartment building, and it was a major fire. There's a lot of people that died. I'm going to be talking about that. And I know I'm getting away from the United States, but to me, that's important because we had a huge fire in Hawaii, Marco Polo, which I was an expert witness on. Also, hazardous building materials, be aware, special inspections, what the code requirements are, construction inspections, how important is it, problems in the construction industry, and then also defective building materials. And that would take us up through November. And in December, we're planning to have a holiday party. Last year, we had a holiday party for website webinar attendees, and we gave away about $1,000 worth of gift cards. So we also have another webinar series on social media marketing. So this party combined our two attendees from both webinar series, and we had a nice party. So that's probably it that I wanted to share, and I want to thank you guys for attending, and like to go into the questions. But before that, you're welcome to ask questions or comments, and if you don't do it right now, you can always email us or give us a call. My email address is lanceluke@hawaiibuildingexpert.com. Phone number 808-422-2132. That's an office line, so you cannot text to that. And then our website, once again, is askbuildingexpert.now.site. And we welcome your questions and comments. And I am remiss, I didn't introduce Martin Pea. He's actually my partner in all of this webinar series. He's a back-end IT guy running the show. He's actually cranking the monkeys to, make the Zoom platform work. And he's also going to be the guy that's going to check our Zoom platform for any questions that come up either on the chat or on the Q&A feature I'm not sure if he's going to check Facebook or not, but I can probably look at that too. But it's interesting. Every time we do these webinars, we have a bunch of people attending on our Zoom platform from not only Hawaii, Honolulu, our main island of Oahu, but we have people from the neighbor islands, Maui, Kauai, uh, Big Island, Kona, Hilo, and then outside of Hawaii, uh, interesting enough, we got people attending from different West Coast cities all the way through New York. And thank you for attending. And we even have some people from outside of the United States in different countries. And although the building codes are different for each country, in general, the basics of the building code is the same. And the other area that is similar is the construction methods, the means and methods of construction, the architect, engineering, design, and even how to build are basically similar. It's just there's different building materials that are used and different types of workmanship. But for the most part, in general, it's pretty much the same. That's why I can give a seminar or webinar on a certain building component and actually applies worldwide, subject to different tweaks here and there of how, like, let's say in Europe, how things are designed, or in Asia. The buildings are basically the same and they look the same, but there's different means and methods that go in depending on the location. So anyway, I'd like to open it up now for Q&A and, get Martin working, because I think he's relaxing in the back end. At the same time, I'm going to try and check my Facebook to see if, there's any comments or questions on Facebook. So Martin, we have anybody that actually typed in any questions on our Zoom platform?
Well, we've got a couple, Lance, or actually 3 here that have come in. So let me hit you with those and then see if anything else comes in. The first question is, what is the reason for all the lawsuits on the new condo buildings? And they're probably talking about Hawaii, where we got them coming up all over the place. Yeah.
So can you repeat the question again?
The question was, what is the reason for all the lawsuits on the new condo buildings?
Oh, okay. Before I answer that, I'd like to give a plug, because some of the answers are contained in our construction defect webinar that we gave. So if you go to our on-demand webinars and look at that, that's kind of explained in greater detail. But in answer to the question, there's, hold on a second, sorry. I'm gonna stop share screen so we can be on the screen here. Okay, so in answer to the question, any construction defect is attributed to 1, 2, or 3 causes. And it could be a combination of 2 or 3, or just one by itself. So it's an issue of poor or inadequate design on the part of an architect or engineer. So the component could have failed because it was not designed properly. The next thing could be maybe the actual building material was defective. So let's say they installed a roof and it started leaking because the roofing product failed. Okay, so that would be a material defect. And the third item is a workmanship issue. The item was not installed correctly, and that's why it failed. So let me give you an example. If you're in a brand new building and there's a plumbing leak, okay, and then they have to opened up the wall to look at the pipe, and then it was determined that the pipe wasn't connected properly. Okay, so there was no material failure. It was a workmanship issue. Okay, in a case of a roof, if there's a roof leak on a brand new building, it may not be the design. It could be partly due to the material failing and also partly due to a workmanship issue. Okay, so then in that case, that's two things wrong. Let's say there's a cracking beam of a condo building in the parking deck. So you go in the basement, you look up and the beam's cracking, okay? And after further research, it's determined that that beam cracked because it was undersized. The engineer didn't design it big enough, and that's why, because of the load, it started to crack and fail. Okay, now that's a design error, okay? And sometimes the designer would blame the material, but concrete, you don't buy it already made, right? You have to make it unless it's a precast already made at a factory and trucked to the construction site. So if it's not that, if it's made on site, then it may not be a material issue. It may be a workmanship issue where the contractor that was mixing the concrete did not follow the proper water to cement ratio, did not vibrate it correctly. He didn't use enough sand. He used the wrong size aggregate. So there could be any number of those factors. So the reason why there's a problem with a construction defect is one, two, or three of those things that I mentioned. It could be one single thing, or it could be two or all three. Now, I could safely say that the majority of percentages of a construction defect is due to poor workmanship. I can say that because I've been involved in a number of construction litigation lawsuits regarding construction defects. So normally that's what it is. So in answer to the question, after my long-winded explanation here, is it's because there's not enough attention to detail and things are happening too fast. In other words, the developer's telling the contractor, we got people ready to move in. Can you hurry up, accelerate your schedule? So then you got these people in the field working as fast as they can. And when you work as fast as you can, or you work fast, you kind of tend to concentrate on getting the job done in a timely manner rather than kind of getting the job done properly, maybe. And, there's been studies done, and it's been proven that when contractors are in a rush, they tend not to do as good of a job as if they had more time, to do the job. So basically, that's what it is. And the other thing is, you may not have, due to the labor shortage, you don't have enough skilled workers. You have workers that aren't journeymen doing journeyman level type work, and that's why maybe that's a contributing cause to a workmanship issue. So hopefully I answered that question. You probably have more questions based on the answer I gave, but I welcome them. So if you have any questions now, ask more again, or contact us later. So Martin, what else do we have?
Well, that's a good answer, and I think you're right. The construction defects can really help get into the details of that. So anyway, the next question here we have is, are the older buildings, which we have a lot of them in Hawaii, with the old low to floor sliding and jalousie windows to code? And then there's a second part here that's asking, is there any requirement to change them?
Okay, so let me give you a little story. The buildings, the high-rise buildings and the condo buildings in Hawaii started off in the 60s, although there was some in the 50s, but for the most part 60s, and we had a huge building boom in the 70s, and then somewhat in the 80s. So I would say between 1960s, 70s, and 80s, we had a huge building boom of buildings and a lot of condominium buildings. So in the 60s and 70s, they were, older building codes, and it was allowable to use windows, plate glass windows that weren't tempered or safety glass. And it was common for a building to be designed with jalousies that were from the floor. I call it floor to ceiling. It doesn't, that term is basically um, windows that are on a floor level. It doesn't have to be all the way to the ceiling, but that's the terminology. And then also, it doesn't have to be jalousie windows. It could be any kind of window that's somebody can open it, that's on the ground or close to the ground. So if your windows are below 36 inches from the floor, that's unsafe if a kid could fall out. Now, if it's a solid glass there, and it's safety glass, it's a better condition, okay? And buildings were designed where they had maybe shelves that were close to the window or built into the wall. So I always recommend, as a building safety expert, that if you have an older building that has windows that could be open that are on the ground, on the floor level, or up to 36 inches in height from your floor, then don't put anything that could be where a kid could climb on it, like a couch. And then even if the window is above 36 inches, but you have a couch there and the couch is 36 inches high, a kid could climb on the couch and just huli over, fall over a window. And if it's on the 26th floor, that's not going to be a nice situation, right? So for safety aspects, protect yourself. The other thing is that, in answer to the question, the building codes back then in the 60s, 70s, 80s, they allowed these kind of conditions, but it's not allowed today. So I would say that those conditions of a window, floor to ceiling, and that could be open, at the floor level or higher, or you could have bars, but if you have a window where you can open it and it's past 4 inches, I would say that's not too safe anyway, if the opening is 4 inches. The bottom line is that the building code accepted that, but by today's standard, it's not to code. Does that mean that you have to replace it? The answer is no, because it's considered grandfathered. And what that means is that at the time of construction, it was acceptable. It's not acceptable now by today's standards or codes. So that's why it's grandfathered in. Now, is it safe? No. Is it allowable by code? Yes. Will the insurance company allow that condition? I would say yes and no. Some do, some don't. I've had situations where insurance companies say, we're not going to renew your policy if you don't fix your windows or fix your railing at your balcony or things like that. So these building owners, condos, and office buildings basically at a mercy of the insurance company. And now it's getting a bit harder. It's not like, okay, insurance company, if you don't want to insure us, that's fine. We're just going to go to the second insurance company down the street. Because of the Florida building collapse and these high-rise fires, more and more insurance companies are not insuring, or they're jacking up their premiums and they're becoming demanding. And they know that there's only, a handful of insurance providers. So let's say in Hawaii, there's only 1, 2, 3, or maybe 4 or 5, not that many that cover and insure condominium buildings. So these companies know that. So they know that if you don't take their offer, okay, of the increased premium, they know that you can't go down the street and call the next guy, because the next guy, their premium is going to be more, or they're going to say, we can't cover you. You know, you had too many claims or something like that. So it's not a easy situation. I've had situations where condo management companies calling me, do you know any insurance companies? Because the one we got is now saying, because we had too many plumbing claims or fires in the building, where now our increased premium is 150,000 a year. Or they say, you know what, if you have one more plumbing leak claim, we're gonna increase your premium to 200,000 a year, or we're gonna cancel your insurance. And it's like, oh, okay, well, so what? We're just gonna go down the street and go to insurance company number 2. They already know insurance company number 2 is not gonna insure them based on their track record. So it's really getting scary out there. And, you know, speaking of fires, it's almost like if we have the next fire, high-rise fire, and there's a death, there's talk around town that the fire department is going to require fire sprinklers in every building, high-rise building over 75 feet. No ifs, ands, or buts. No allowances or Mickey Mousing around or anything like that. They don't care how many condo associations, apartment building owners protest that. Okay, so it's just not, you know, if it's going to happen, it's kind of when it's going to happen, what year it's going to happen, and all that. I hope it doesn't happen, but you know, who knows? We can't predict the future. So another long-winded answer, but I think I covered the question.
That was a good answer, Lance. You always give good, thorough, thought-provoking answers, so.
Well, you know why? Because are we getting paid for this?
Of course. Now we got one more that came in. Let me throw this one at you before we run out of time here. Are most new buildings today using the curtain wall system versus, I guess, the other one you talked about, the window wall? Yeah.
Oh, okay. Most buildings today are designed for the maximum view. Especially, and I use Kaka'ako as an example. Kaka'ako is in an area where you have views of the ocean and it's really close. And the architects are designing the building, the location and the angle of the building to attain the maximum view plane, you know, from each condo unit. The other thing is when you're in the unit is only so many square feet. So if you have too many walls and not enough windows, you don't get the view. So the idea is to design the building with the maximum view available. So the bigger, imagine if you have a small picture window and, you know, looking at the ocean and the rest was all concrete wall. You don't want that. Right, so you want to, the objective is you want to take out solid wall and make this whole wall one huge window, okay? Or if it's not a huge window, you know, a couple of huge windows to fit. And that's the idea, so that when you look out, you don't have any building wall in your unit blocking your view. You have mostly the whole window view to look at. Now, that's the best case scenario, provided you don't have another building in the way, or part of a building in the way, or trees if you're on the lower floor or something like that. So the objective with the curtain wall system is to achieve that, the maximum design for the view. And as you know, when you're building a high-rise building as a developer, the higher the floor, the better the view. And the higher the floor, you can charge more money. And that's why when units are being appraised, the higher the unit, the more value there is, you know, as opposed to a lower unit, because you got a better view. Okay, so you know, that's the objective. And to the developer and to a condo unit owner, if you live on a penthouse or a high floor, you can actually get more money than if it was on a lower floor. So, real estate agents know that. And, provided all things being equal, the unit sizes are the same and all that. So the concept of the curtain wall, works best. And the more view, the better on these buildings. So, that's what's really happening. So, Martin, we have any other questions or comments or
No,
anything
no,
like
that's
that?
all, that's all we got from our Zoom audience and our Facebook audience. They're not as questioning as when you do your lives, but they'll come around. Your
Okay,
live at,
well,
yeah.
so you check Facebook also.
Yes, yes, I did.
Okay,
I did, yeah.
well, it's interesting because after the live ends, then comments come in later, and which is okay. And it's like our Zoom platform. I mean, we welcome comments from the audience, comments or questions and things like that. We're nice guys, and the best part of these webinars is educational for building and health and safety of buildings. And the best thing, it's free. So take advantage. At a certain point, we'll be charging admission. We'll start up our own, Netflix account or something. But anyway, we have fun doing this, and hopefully, you guys in the audience, learn something. If you can pick up a few tips here and there, that's good. I myself get a lot of comments from all over the United States because I'm a national building expert, and I welcome those comments, although it takes time to respond. But that's what we like to do. We like to help people in whatever way we can. I've even had situations where I got an email from somebody asking questions, and I respond, and then later on I find out that they were involved in a lawsuit, and they were on the opposite side of the side that I was on, hired as an expert by the attorney. So that was a little hairy, but when I found out, then I told the attorney, and he sent them a letter. So I guess they were trying to bypass and get information without revealing, who they were and all that. So anyway, that's it for today. Thank you for attending, and we'll look forward to you attending our next webinar, which is about lot grade and drainage conditions. And speaking of that topic, this would apply not only to a single family house or a townhouse or a subdivision, it will also apply to condo and office buildings or shopping centers, because anytime you have a site where there's no building there and you're going to construct a building, there's things that are involved with respect to drainage. There's soil conditions, there's site conditions, and a lot of times on a new building, well, not a lot of times, but in every single instance, when you're building a new building, like a high-rise building, the developer hires a architect who then hires a geotechnical engineer, which is a fancy term for a soils engineer. So they would test the soil, and from their results of the soil evaluation, they would advise the civil engineer, who's in charge of designing a grading plan and drainage conditions and all that. So you got those two engineers working together, and then the structural engineer comes in and he goes, okay, based on the soil condition and drainage, I'm going to design a foundation, with this type of foundation and all that. And those are basically the key players in the soil, drainage, and the structural foundation. So it's very important. There's a lot of moving parts in any kind of building, even a house. One house is a lot of moving parts, and it's different today than back then in the 50s. In the 50s, all these single wall construction houses, no one did soil testing. You just cleared the lot and said, okay, we're good to go. And, you know, it's a raised foundation built on tofu blocks. And that was the design back then. That was a code back then, and it was acceptable. And now if you have a big hurricane, all these houses will just blow away, basically. You know, I'm just being drastic. It's not going to be that bad, but that's basically an evaluation for structural wise and hurricane load. That's basically what the synopsis is. You know, your house could blow away or your roof could blow off. And over time, new codes were developed. New code changes every 3 years. So you got to keep on top of it. And for the people who don't keep on top of it, they don't have the correct information. So that's what we're all about here, to give the facts, to give the correct information, and to provide you with the best information that we can give you as possible. And personally, in the field, I'm arguing all the time with contractors and architects, and not too many engineers, but you know, homeowners, right? Property managers, some developers, mainly contractors, who, when I have to review something and I tell the client, you need a building permit for this, and the client tells me, oh, my contractor says that I don't. And I have various accounts with condominium buildings who hired me as the building consultant to review their design plans, and someone wants to renovate their unit. And when I'm talking condo unit, it could be in a high-rise building or it could be in a townhouse situation. And so I'm like the gatekeeper, and people don't like it, and they want to argue, and I just give them the facts. I just got to keep giving them the facts, because there are so many myths out there. And that's why it led me to build a website that Martin and I are going to build. I think the name is something like Prevent Contractor Ripoff or something like that. But anyway, these websites that we're building is basically you know, public service websites to provide public service information, and that's going to be the resource. So if there's any question about a building permit, a building code, or if the contractor has to be licensed or not, the website will be there as reference for people to go to. And the information on the website is factual. It's not like, I think that here's what the rule is. It's not going to be, I think, or I guess what it is. It's going to be the real facts. It's going to basically say, I know what the rules are and the regulations, and here's what I'm saying about it. Okay. And people can argue all the time, but I figure it's easier for me. Then I just say, hey, if you don't believe me, go to the website and look, or call the city DPP yourself, or call the state contractors license board and ask them the question and see what they say. We're actually the Wikipedia of building information, building and construction information. We want to be the resource, the, you know, Encyclopedia Britannica kind of thing. We want to be that, and I think we are. We're getting to that, and I welcome comments. If contractors or other people, architects, have questions or they don't agree with what I'm saying, fine. You know, I welcome the lively and active discussion, and that's what we're here for. So once again, I know time's up. If we go overboard, we have to charge you more for attending the webinar. But once again, thank you for attending, and we look forward to seeing you at our next webinar. Until then, aloha from Martin and myself. See you later.